All right, here are the notes for 1.5. We're going to look at some angle pairs. And this is actually laying a foundation for pretty much the rest of the semester and the year, looking at different types of angles. Okay. Here I just kind of copied and pasted from the note solutions, but I'll just kind of talk about these. 3 and 4 are ones that might sound familiar from like earlier years when you guys learned about angles. Remember, complementary angles are angles that add to 90, and then supplementary are angles that add up to 180. Okay, um, and you got to know that. Okay, and so here, um, this matches up with B, right? Angle 1 and angle 2, because angle 1 and angle 2 add up to 90 degrees here, right? And here, angles A and B, when you add those up, they're 90 degrees, right? And here, supplementary is C. You can tell that they add up to 180. I believe in the notes, this one, angle 3 and angle 4, it makes a straight angle, right? A straight angle is 180 degrees. Number 2, adjacent angles. Remember, adjacent means next to. Okay, so this goes with part A because angle 1 and angle 2 are next to each other, right? And angle 3 and angle 4 are also next to each other. Okay. Number 1, vertical angles. This is going to come up a lot, all right, in this semester. Vertical angles are two angles whose sides are opposite rays and the opposite angles formed by intersecting lines. So I think it's best to just look at the diagram, right? Like 1 and 2, they are across from each other, right? And 3 and 4 are across from each other. So those are vertical angles, okay? Um, we're going to get into this a little bit later, but vertical angles are always congruent, all right? So angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, all right? They have the same measure, okay? So those are the different types of angles. Um, here, if you want to pause it, and it's just a little matching activity, okay, based on this diagram. And so if you want, you can pause it here and play it when you're ready and before you look at the answers. All right, so here are the answers, okay. I want to point out for adjacent, right, you have 2 and 3, okay. You could also do like 2 and 1, right? You could do 1 and 6. You could do 6 and 5, and 5 and 4, and 4 and 3, right? Because they're all next to each other. For vertical angles, let me also point out that you can have 1 and 4, right? Not 1 and 5, okay, but 1 and 4 because these are across from each other, as well as 3 and 6, okay? And so you got to start getting familiar with these vertical angles here. Here I just kind of again copied and pasted the notes. Um, based on these diagrams, are these statements true? Okay. Um, I want to point out for part B, AFB, this angle here, AFB, and EFD, okay, they are not vertical angles, right? If anything, if they are going to be vertical angles, all right, EFD, here's EFD, right? Then the vertical angle to EFD is actually AFC, AFC, okay? For part C, these are not supplementary, they're not, or they don't add up to 180 degrees, okay? Okay, this is really important. This is talking about like any diagram as we move forward in geometry, okay? Here's what you cannot conclude. Let me start with the negatives, okay? You cannot assume and conclude that angles are right angles or 90 degrees, okay? You have to be given that little square, right, to indicate that it's 90 degrees, or it'll tell you with the number 90, okay, or it'll verbally say that it is a right angle, okay. But if you have a picture and it looks like 90 degrees, you just cannot automatically assume that, okay. Um, you cannot also assume and conclude congruent segments or angles without markings. All right, we're gonna see a couple examples of that. So just because it looks like it doesn't mean that you can assume it. Okay. You can conclude adjacent angles, right? That doesn't mean that they're congruent, but you can obviously assume that they're next to each other. You can assume adjacent supplementary angles, right? If they make a straight angle, you know that it's going to add to 180. And you can assume and conclude vertical angles are congruent. Okay, so those are the things you can conclude and what you cannot. So in example 2 here, all right, what can you conclude from the diagram? All right, if you want, again, pause it here and then write down or think about what are some things you can conclude. I'll give you one thing here. You can conclude that angles 2 and 3 are adjacent. They're next to each other. All right. So pause it here if you'd like and think about it. And then press play when you're ready. All right. Here's everything you can conclude. Right. 1 and 2 are congruent because they have that marking. Right. Those little arcs. That means those angles are congruent. Okay. You can assume that 3 and 5 are also congruent. They are vertical angles. And then you have a bunch of these adjacent angles, right? Here's all these different pairs. And also you can assume adjacent supplementary angles, like 3 and 4, okay? All right? So those are all the things that you can conclude. Again, if you want, pause it here to look these over, okay? Here's also what you can conclude, all right? TW and WV, you can conclude that they are congruent because it's marked. So when you have a tick mark like that, that means these segments are congruent to each other. Okay, we don't know the measure, but that doesn't matter. All right, we're saying that the measure of TW is the same as WV. Okay, PW and WQ, you cannot automatically assume it. It might look like it, possibly, but there's no marking. Let's say if it had a marking like this, okay, then they would be congruent to each other. All right. By the way, you would need 2 tick marks here because TW and WV already had 1 tick mark. Okay. All right. So there's no indication that they're congruent. All right. So I'm going to erase this. TWQ is a right angle. It might look like it's 90 degrees, but you can't assume it. All right. You would need to be given that little square, right? You need to be given that, or it should say somewhere, or actually, if it says like 90 degrees, or if it tells you somewhere that it's a right angle, okay? And again, same thing with D. There's no indication that TV is a bisector of PQ, meaning that it splits it in half, all right? And just a couple last things to wrap up 1.5. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays, meaning they make a straight angle, right? And so here, angle ABD, right? Let's label that as angle 1, and angle DBC, angle 2, they're next to each other. But here's a key word, linear, right? It makes a line, right? You have this straight angle ABC here, okay? An angle bisector is a ray that divides an angle to 2 congruent angles, okay? So here you would say that angle XAY is congruent to angle YAZ. All right. Okay, so that's what an angle bisector is. And so obviously you would just divide the whole angle into two. Okay. And that's it for 1.5.